2020 한노 스마트시티 세미나에 참석해 주신 여러분 감사 말씀드립니다. 안녕하십니까? 저는 사회를 맡은 박인수입니다. 편의를 위해 지금부터는 언어를 영어로 진행하도록 하겠습니다. Dear participants, ladies and gentlemen, it is my great pleasure to welcome you all today to 2020 Norway-Korea Smart City Online Seminar. My name is Jason from Innovation Norway, and it is my honor to be your host today. This is the fourth Smart City Seminar between Norway and the Republic of Korea since 2018, and it is co-hosted by the Embassy of Norway in Korea, the Embassy of the Republic Korea in Norway, and Innovation Norway. Each year, we have carefully selected the focus areas for the smart cities, and for this year, 3 topics were selected as shown in the program to strengthen the collaboration. Due to COVID-19 global pandemic, we chose to have this seminar online for this year, and we wish to hold this seminar offline again when the time allows. Before we commence our seminar, I'm sure you're probably all quite used to the virtual meetings by now. Nevertheless, a quick reminder of a few things. 1, for this seminar, it is aired via Zoom as well as YouTube with Korean-English interpretation. For Zoom, look for the interpretation button on the black bar at the bottom of your Zoom screen. It looks like a globe. Click on the globe button to select the language you would like to listen to. 2, we would like to ask you to keep your microphone muted at all times when you're not speaking. 3, if you experience any difficulties during this seminar, you can mention it in the chat or send the message to the host. Lastly, we will share today's presentation file by Friday this week with the consent of speakers. Without further ado, let me introduce the first speaker of the day who will give the opening speech. Ambassador Frode Solveig is the Norwegian ambassador to Korea, and he joined the Norwegian Ministry of Foreign Affairs in 1995. He has experience from Norway as well as Norwegian embassies abroad in Stockholm, Berlin, Vienna, and Abu Dhabi. Please welcome Ambassador Solveig.
Thank you very much, Jason. Distinguished guests, dear friends, good morning and annyeonghaseyo. I would like to start out by thanking you all for taking part in today's Smart Seminar, both participants and speakers, and not least my dear colleague and friend in Oslo, Ambassador Young-Suk Nam. Once again, we are hosting this seminar on a digital platform, and I really miss seeing you all. However, I'm also proud of the fact that we, despite these challenging times, are able to meet and discuss important topics. And the upside with these digital events is that more people can join and can enjoy insights and updates from experts around the globe in just a few hours. That in itself is actually part of what's on the agenda today: smart thinking, smart solutions. The world as we know it is changing. Climate change, increasing populations, but also aging populations in many countries push forward the need for major economic and environmental restructuring. These trends are accelerating, and this year the global COVID-19 pandemic has underlined the need for change and the need for smart solutions, key to a world that is increasingly interconnected and with a population that in just a few years will pass 8 billion people. We have to make sure that the growth required for this population must take place within the boundaries of our planet. And with a growing part of this population living in cities, we need to make these cities sustainable, smart and green. And cities that are nice to live in and that can improve the quality of life for their inhabitants, but also use resources in the best possible way, increase productivity, and reduce climate impact. And perhaps even contribute positively to the highly required green change. This is not an easy task, but indeed a necessary task, especially if we are to reach the United Nations Sustainable Development Goals. South Korea is taking bold steps towards a society less dependent on fossil fuels and more on renewable energy resources. Many steps have been taken this year, among others the ambitious Green New Deal and President Moon Jae-in's announcement on carbon neutrality by 2050. This change entails a dramatic transformation, a change where sustainable growth is at the core, a change that will create new and innovative jobs and improved quality of life for many, and a change where smart cities will play a crucial role. A central aspect of the smart city concept focuses on the cooperation between people and technology. But we also have to focus on cooperation between people. An important part of the Norwegian approach towards smart cities is the development of strong partnerships at home and abroad. And as we talked about, sustainable growth is also high on the agenda of my government, and we need to find the solutions for the future together. And the framework for closer cooperation within this specific area is there. We already work closely together within a number of topics, and together we will soon hopefully present a new MOU that will further strengthen the cooperation on smart city development. The intention is to enable exchanges of policies, technologies, and information, as well as to enable the development of smart city industries in both our countries. One objective is also to inspire to the cooperation of regions, cities, local authorities, or individuals in the private or public sectors, and not least, aim to encourage businesses of the two countries to explore potential business opportunities and our relations. Dear friends, Norway does not have the megacities like Seoul and Busan, and sometimes the challenges in our countries are different. But Norwegian cities rank high on smart city rankings. We have a highly developed smart city ecosystem, and Norwegians are digitally advanced, thus giving us an excellent platform for future development. I'm sure that today's seminar will give participants the opportunity to learn more about the smart city development in both our countries, and also to become familiar with companies and institutions, and not least in which way they are heading. That gives an excellent possibility to identify areas and partners for future cooperation. And based on our long-standing close cooperation, and not least our complementary expertise and background in many areas, Norway and the Republic of Korea have a great opportunity to find solutions for tomorrow together. Thank you very much for your attention, and I wish you a very pleasant, interesting, and meaningful seminar today. Thank you. 감사합니다.
Thank you, Ambassador Frode Solveig. Thank you very much. And then especially I liked some of the things you mentioned, inclusive and involve people in it in the smart city. And we're really also looking forward to have this new MOU in place soon, very soon. Thank you very much once again. And we would like to go to our next speaker, the Ambassador Young Sung Nam, who will give the welcome address. Ambassador Nam is the current ambassador to Norway since 2018, and she was a former Secretary General from the World Smart Sustainable Cities Organization, so-called WeGo. Ambassador Nam, floor is yours.
Thank you. Dear Excellencies, colleagues, distinguished speakers and participants, as a Korean ambassador to Norway, it is my great honor and pleasure to be able to speak at today's webinar. First of all, I'd like to thank Ambassador Frode Solveig for all the help and preparation carried out by your embassy in Seoul. I would also like to extend my sincere gratitude to Innovation Norway for their continual generous and professional support for the series of Norway-Korea Smart City seminars that we have co-organized since 2018. Norway has set the pace in the development of smart sustainable cities and communities. The Norwegian government supports and encourages digital transformation in the public sector, and a broad-based group of public and private actors developed and launched the Norwegian National Roadmap for Smart and Sustainable Cities and Communities as a blueprint for municipalities. It is now evolving and expanding into a Nordic roadmap in collaboration with smart city hubs throughout the Nordic countries. Norway and Korea are both leading maritime and ocean nations, and the two countries have been collaborating closely in the maritime sector since the bilateral diplomatic relation was established 61 years ago. Norway is a world leader in the development of smart and autonomous maritime transport systems with an impressive rigor pushing progress in the field. It is home to many leading companies such as Kongsberg, Mastery, and many more. Norway is a particularly conducive testing ground for autonomous solutions, given the great variation in seasons and harsh environment. In that regard, the collaboration with Korean companies such as Hyundai Heavy Industries, DSME, Samsung Heavy Industries, and national institutes like CRISO will allow both nations to synergize not only in terms of technology exchange, but also to meet and exceed international standards and regulations. Smart weather is another potentially promising area of collaboration. Last year, I had the pleasure of visiting the Bjerknes Center for Climate Research in Bergen, which is one of the largest climate research institutes in Europe. The center is named in honor of Norwegian visionary meteorologist Wilhelm Bjerknes and Jakob Bjerknes, a father and son, who laid the foundation for modern meteorology and weather forecasting through the Bergen School of Meteorology. There is a fascinating story that I learned about how critical Norwegian weather forecasting was to the success of the Normandy landings during the World War II, which led to the liberation of German-occupied France and later Western Europe. At that time, correctly forecasting the weather condition was absolutely imperative to the success of the landing operations and associated airborne operations on D-Day. General Eisenhower, the supreme commander of the Allied forces in Europe, had originally set a D-Day, but later he was able to postpone it by 1 day thanks to the weather forecasting done by Norwegian meteorologist Sverre Pettersen, who used forecasting method developed by the Bergen School. The weather forecast turned out to be correct, and the operation was hugely successful. With the current effort of advancing meteorology in Korea, a South Korean fixed satellite, the Charlian-2B, was launched to observe Korean daily weather and find us on October 20 this year. I believe there's a lot more we can do together using both nations' weather data and technologies in areas such as autonomous mobility, climate resilience, and adaptations in which weather data would be critical. The Norwegian government has been pursuing an ambitious climate and environment policy, shifting its focus to hydrogen energy. In the crisis package presented to Parliament in May this year, the Norwegian government announced an increased focus on hydrogen-related research and technology as a ways to meet the challenges. In June, the government announced a new hydrogen strategy, laying the foundation for the government's further work on hydrogen. In June last year, during President Moon Jae-in's state visit to Norway, the two countries signed an MOU to cooperate in the hydrogen economy and low-carbon technology. I believe that there's ample opportunity for cooperation to augment both nations' strengths, that is Korea's hydrogen-powered vehicles, and Norway's production and supply capabilities. Many exciting changes are coming in the near future, and both countries will collaborate on the new method of powering hydrogen ships. Innovation has been a key driver of both Norway and Korea's development. This is not coincidental, but rather requires creativity and planning. I hope today's seminar will provide a very useful forum for the two countries' innovators, municipalities, startups, companies, and researchers to seize the opportunities and build partnerships for cross-border, cross-city collaboration. Tusen takk. Thank you.
Thank you very much, Ambassador Nam. That was a very, very actually fun story to listen to about the Normandy landing. And then also, I heard that the MOU between the two nations on hydrogen was actually Korea and Norway was the first nation to sign that MOU. So I am very grateful for that. Thank you very much once again. Let us start our first topic of the day, which is the smart ship. We have Ornulf Jan Rodseth from Norway. He's one of the world leading experts on unmanned and autonomous ships with more than 25 years of experience in information and communication technology for ships and onboard system. Ornulf, are you there? Okay, thank you very much. The floor is yours. Please.
Thank you. Let's see if we can get the presentation up.
Clear to see it?
It's a full screen.
No, it's still presentation. No, not yet.
There we are. Okay. Thank you and welcome everybody. It's a pleasure to speak to our Korean colleagues again. We have a very good cooperation with Korea and I hope that will continue. The title of the speak is Outlook of Smart Ship, but actually we could have called it Smart Ships in Smart Cities. I think both Norway and Korea has a lot of cities which are close to the waterways. So waterborne transport is part of smart ships in both countries. First, I will give you a brief overview of what we are doing on autonomous ship technology in Norway. We have at the time two commercial projects going. One is the fairly well-known Yara Birkeland. The ship was handed over to Yara last week and will commence testing now in south of Norway towards going into operation later in 2021. There's also a new project where plate cutting started also a couple of weeks ago in India. That's for a wholesale distributor, ASCO Maritime. And that will be two small ferries. They will be manned from 2022 when they come to Norway. And the plan is to make them uncrewed by 2024. Interestingly enough, both these systems are electric and emission-free. And the intention is to get truck traffic off the roads. In addition, we also have a lot of other large projects, among them AutoShip, which is an EU-funded project with a budget of more than 30 million euros, which is about the same in US dollars, a bit more actually. And also another one, which is about 7.5 million euros. We also started this year a research-based innovation center operated by the Norwegian University of Technology and Science in Trondheim, but with cooperation from SINTEF, my own organization. That will operate for 8 years, and the starting budget there is about 25 million euros. And a lot of other projects that I will not go into. So there is a very heavy emphasis on autonomous and smart shipping in Norway. We should also mention the ocean laboratory facilities in Trondheim, which is connected to the Ocean Space Center we are building here at the cost of about 400 million US dollars. So again, a big effort. And we also have a lot of network activities with the Norwegian Forum for Autonomous Ships, the International Forum. We recently had the ICMAS conference in Ulsan a couple of weeks ago, and we had the International Ship Autonomy Summit yesterday in Brussels. And we also work quite a lot with international standards and IMO, together also with our Korean colleagues. So, why autonomous ships in smart cities? Actually, it's very closely connected to the global development and sustainability goals. One thing is, as I mentioned, new types of energy, carbon-free transport, and similar issues, where battery-powered ships is part of this. And in general, what we see with autonomous ships is that they typically can be built smaller because you don't have crew. So you don't have the overhead with the accommodation section and the cost of the crew. And when you build smaller ships, you can build them differently, and it's easier to operate them with alternative fuels. Today, it's mostly batteries, but there are also people looking at hydrogen, ammonia, and other types of fuels. The other thing we can do with smaller ships and more flexible waterborne transport is to build new types of transport systems, which is directly taking us to the smart city problem. As I mentioned, waterborne is and can certainly be more sustainable than, for instance, cars and truck transport. Queues and area use is a big problem, also in cities. Where are we going to put all these big trucks? We are going towards electric transport in Norway, but still we have a lot of dust and particulate matter, which is a big problem in certain areas. So even if you get to non-carbon fuels in the cars, it doesn't mean that they don't pollute. In Norway, we use about 20 times as much money on investments in road than in sea transport. That is, of course, connected to the importance of road transport for public and person transport. But in Norway, we transport about the same amount of cargo in ton miles on sea as on road. So in a sense, you could say that seaborne transport is about 20 times as efficient in terms of money per ton mile. And noise, of course, is very important. Both the new project I showed you, they are electric and very silent. And one of the issues they are really concerned about is reducing the noise for the population living close to these ports. And this is a big problem also, even in Norway, which the picture you see, or maybe see, is from Oslo, and it shows the noise pollution on the main roads in Oslo. And that's a relatively small city with about 700,000 people. So if we can make better use of waterborne transport, this can certainly help also the sustainability goals of the cities. A very interesting point is to get a better utilization of the urban waterways. As I mentioned, a lot of the cities in Norway, as well as in Korea, is close to various either rivers or sea. And if you can build small boats that can replace bridges, you can get a much more flexible and cost-effective transport system utilizing the waterways in totally new ways. Today, it's a bit expensive operating ferries because you have to have a full crew. They are quite large. But we have two companies in Norway now, which you can see to the right. One is Hydrolift, which is working on small ferries up to 50 persons, which eventually will be fully unmanned. And the other is a new one called Seabus, which are looking at smaller concepts, 12 to 20 people perhaps. And we expect that the first Seabus ferry will be operating in Trondheim from the summer next year. So please come to Trondheim and have a look at that. That will probably have people on board the first couple of years just to make sure that everything works as it should. But still, the aim is to have a fully unmanned, on-demand ferry. It's about 60 meters crossing over a river, but you save about 15 minutes walking. So it's a very nice concept. And this is something I've seen myself in, for instance, Busan. There's a lot of waterways that could be utilized much better if you have solutions like this. Certainly smart. Another problem we are seeing in Norway is that the port areas in the cities are under pressure. It's high value real estate. They use a lot of area, and they use a lot of area in the most attractive spaces. So many of the ports in Norway is now considering moving out of the city center and out to the outskirts of the populated area. And that, of course, causes a transport problem from the port to the city. The picture is from Trondheim. So one of the projects we are looking at is if you move the port out of the city, how do we transport the cargo into the city without using trucks? And again, smaller shuttle vessels sailing in protected waters fully autonomously seem to be an interesting option. We have a project based here in Trondheim. This is a research project, so we will not demonstrate it. But the point is to move the port out to the main fairway, and the big ships will save about 5 hours sailing into Trondheim and back again. While we can replace these with smaller unmanned ships with electric propulsion, very silent and small enough so that you don't need the big terminal areas. It's more delivering a container on the quayside and getting it up into the city immediately. Again, a very interesting proposition, I think. And again, something that, for instance, could be interesting for Busan, which have moved the container port out of the city. So, to conclude, there are very rapid developments today with in the area of autonomous ships. Some of you may have listened to the summit yesterday, and I think the basic conclusion we made there is that this is going relatively fast, although there is still some worries about how to use these systems in various applications. It's a very high sustainability focus, both in terms of fuel use, but also in building new types of infrastructure. In my mind, autonomous and uncrewed ships is a game changer. It's disruptive technology that can change transport, at least waterborne transport, totally from what we are used to today. And one part of this is the sustainability focus on new types of infrastructures, which are more fitting to modern cities and the needs we will have also there. And as I said, autonomous ships, new developments offer new opportunities, which are very interesting in my head, at least for waterborne transport in cities, both for passengers and for cargo. So, thank you. That was my message for today.
Thank you very much, Olof. I think you're still on the speaker mode. Can you put that on the mute? Thank you very much. Thank you, Olof. And then it was really, really interesting. Not only giving us the insight about the water transportation, but also new ways of doing the waterborne for the passengers as well as the cargo ship. I wish I can be the first to visit the beautiful city of Trondheim and try that small scale waterborne. I wish that time comes very soon. Thank you very much once again. Our next speaker is Jin Kim from Korea. He is a principal researcher at the Korea Research Institute of Ship and Ocean Engineering. From June this year, he has been working as a project head of Korea Autonomous Surface Ship Project Office. Mr. Kim, are you there?
Yes, do you hear me?
Yes, I can hear you.
Okay, good.
Yes.
Yeah, okay. Thank you, Jason, Insu. And also, nice to see you again, Olof. Actually, we met yesterday's summit. So good morning in Norway, and also good afternoon in Korea. I'm Jin Kim, the project head of the Korea Autonomous Surface Ship project. We launched the National Korean Autonomous Surface Ship project June this year, which is supported by Research Fund of Korean government. Today, let me briefly introduce this CAS project and its verification and validation plan. In early 2010, EU initiated the concept of autonomous ship, and they studied the feasibility of the couple of test bed under the name of Munin project. Also, Rolls-Royce in UK, which is now merged to Kongsberg Maritime, maybe, started AAWA, Advanced Autonomous Waterborne Application Initiative project in 2013, which is targeted coastal remote operation in 2017, and finally fully autonomous unmanned ocean going by 2035. And actually, the owner mentioned in his presentation, Norway also in Kongsberg and Yara started Yara Falkland project. And also Japan and China is developing very similar concept of autonomous ships. Korea started Korea Autonomous Surface Ship project, CAS. The project is jointly funded by the Ministry of Trade, Industry and Energy and the Ministry of Oceans and Fisheries to develop mass technologies, which consists of 4 key technologies with 13 sub-projects. Time frame is total 6 years from this year to 2025. The vision of this project is of Korea taking the lead on future market share and international standards for the autonomous ships. And the objectives are: the first technological target is to develop mass equipped with an intelligent navigation system that would meet the autonomy level 3 of IMO for ocean going, and the level 2 for coastal operations. We'll make efforts to achieve global level reliability and standardization so that we expect Korea would take the lead on mass market share. For these objectives, we launched the National CAS project, which consists of 4 key technologies, such as autonomous navigation system, autonomous engine system, sea test bed and validation technology, and operation techniques and standardization. Let me show the members of CAS consortium. The CRISO, Korea Research Institute of Ships and Ocean Engineering, and Korean Register take charge in project managing, and Korean shipbuilding companies, Korean shipping companies, and small IT ventures, and many Korean marine equipment companies are participating in this project. In particular, Lloyd Register in UK joined this project for the development of validation procedures together. In order to manage and also help the development of the 4 core technologies, the CAS project office is organized. This office consists of project head and vice head and staffs. We'll operate a civil commission for important decision making and advice. We're considering 3-phased validation steps, including simulation and small test ship and the actual commercial ship test. In terms of validation for mass digital system, no appropriate procedures exist so far. We'll also develop the procedures for checking and validating all digital systems of mass. The procedure development will be carried out in cooperation with the Lloyd Register. Lloyd Register is only participant from other countries in this project. The first step is simulation-based testbed for autonomous ship. We named it as STAS. We'll simulate a test ship with virtual other ships, virtual obstacles under the virtual ocean environment. The key technology for STAS would be VDGS, which means Virtual Data Generation System. It will be developed including marine obstacles, marine weather environment, and scenario for testing. The STAS system will be equipped at Mass Control Center at the shore. The next step is testing a real ship at real ocean environment. Real ship and ocean environment replace virtual conditions of a simulation-based system. Two real ships, such as a 24-meter class small test ship and a commercial ship provided by participating shipping company, will be tested in this project. We can use both VDGS generated virtual obstacles and also together real obstacles. The sea test bed, including Mass Control Center, will be constructed at Ulsan City, which is by southeastern coast of Korean Peninsula, and is very close to the Ulsan shipbuilding yard of Hyundai Heavy Industry. We'll build a small test ship. The ship's main particulars are shown here. The test will launch at the end of next year. The situation awareness system with sensors and digital bridge with autonomous navigation system will be equipped on this test ship. However, the engine automation system is not easy to test and validate with a small test ship. So, in a stage of technology development, we'll use an actual full-scale size main engine within a simulated environment. Various big data with artificial unintentional, malfunction will be collected. These big data will be used to develop condition-based management CBM solution with all AI technologies. Digital bridge and platform on shipboard and digital twin bridge at Mass Control Center will communicate together with the various types of communication system. We also developed the cybersecurity system. It will be applied and tested for both digital bridge and digital twin bridge. The shipboard digital bridge collects all data and intercommunicate with the intelligent navigation system and engine automation system. The digital twin bridge and Mass Control Center collect all shore data, including VTS information, and operate a big data platform, and will have a remote control ability in an emergency situation. it is the concept of drawing of a sea test bed at Ulsan City. Mass Control Center will have a digital twin bridge and a big data platform and communicate with the shipboard digital bridge. We'll develop the test scenarios and procedures to validate the intelligent navigation system and engine automation system, including cybersecurity. The Korean private companies will have R&D products such as engine automation system, situation awareness system, intelligent navigation system, and communication system, etc. The commercial operation of mass in the future will strongly depend on how to get an accreditation or approval in safety and security points. The CAS project will develop the procedures for checking and validating all digital systems of mass. So we would like to cooperate with all other nations in order to make the international standard of mass verification, validation, and accreditation. The CAS project will help the participating private Korean companies to get the track record to make their business model themselves. Thank you very much.
Thank you, Dr. Jin Kim, for the wonderful presentation. And it is really exciting to hear that there is going to be an actual shipbuilding to test autonomous ship. Before we go to next, I just have one small question, both for Jin Kim and Ornov. For Jin Kim, I know you're already collaborating with Norway in terms of autonomous ships. Where do you see that the collaboration in what sector will come to very early stage?
Actually, we are doing very similar research work in both Korea and Norway. So at this moment, I would like to suggest two types of cooperation between Norway and Korea. The first one is about the validation of mass digital system. All of us have been hearing a couple of successful operation of mass, even including unmanned. However, there is no procedure or validation method to get an approval for international voyage yet. So I would like to cooperate to set up the procedure for validation of a mass digital system. For example, situation awareness or collision avoidance, etc. And also for the second, we'll develop the STAS, simulation-based test bed for autonomous ship. So I think Norway also have a simulation-based technology for testing mass. So I would like to build a co-simulation platform together, which we can operate each virtual autonomous ship in each other's simulation environment and make many test scenarios together. Yeah, at this moment, I think that's it.
Thanks very much. Thanks very much. Actually, that's one part of our smart city cooperation between Norway and Korea is thinking of having the cross validation of certain elements. Ernov, there's actually a question from Young-ho Yu. I know, I'm pretty sure you know who he is. And then he actually is asking a question about Yara projects becoming late and what would be the reason that Yara test results is coming out late, and when do you forecast this will come?
Yeah, thank you. As I understand it, the main problem that Yara encountered was on the cargo handling on shore. They were aiming for full automation of cargo handling, and that was too expensive and too complicated. The ship is fairly okay, but that also was delayed a bit, mainly due to the COVID situation. But as I said, Yara Birkeland is now finished, outfitted. It has moved down to the Porsgrunn area and handed over to Yara. So it will now start testing in the south of Norway with people from Kongsberg and Yara on board. And the expectation is that it will go into manned operation later in 2021, autumn. So again, cargo handling, and just to make a point of it, cargo handling is extremely important and very complicated. So that's also something we should work on together. And just to add to Jin Kim's comment, everything related to standards is important. Testing, digital interfaces and stuff like that. This is something we have to agree on in any case internationally. So it's a very useful. We can compete on the technology, we should do that, but we also need to cooperate to get this moving. Thank you.
Very good point, Arno. Very, very good point. I completely agree. Thanks very much. We have a couple more speakers to come. So let us start our second topic of the day, which is the smart weather. And we have Tolef Markussen Lunde and Reza Argahande from StormGeo in Norway. Tolef is responsible for innovation of StormGeo Weather Insights global products and service. For Raza, he has more than 10 years of academic and industrial experience in data analytics for smart grid and smart city. Both of you, are you there?
Yes. Tolef here.
Okay, thank you very much. Yes, and then floor is yours. Please carry on.
Thank you so much. So I will share this one. So thank you very much for very good presentations.
Oh, sorry,
and very
Tolef, we don't see you now. Have you turned your cameras on yet?
yes. So I'm not allowed to turn on the camera. It says.
Oh, you're not allowed? No, I think. Can you try it once again?
No, I can. No, I think it
now
can
we
work.
see you. We see
yes,
you.
and
We
you also
now.
see the screen.
Yes, I can see you.
Yes, I can. Thank you very much. Perfect.
Brilliant. Yes, so thank you very much for inviting us for this talk today. And as you mentioned, today we're present Reza Argandao, professor of HBL, previous assistant professor of University of Florida and Berkeley, and myself, the head of innovation in StormGeo. So first, very short about StormGeo for those who don't know the company. So what we do is providing weather services to many different weather exposed segments. So you can see on the left here that we have shipping, oil and gas, renewables, land-based industry, and media. And we are an organization that is distributed all around the world, with offices in the US, Europe, and Asia. So by far the largest segment that we operate in is shipping, and we actually have software installed on approximately 1/3 of all the soulless ships worldwide. I'll talk more later about what kind of software we have on board there. In oil and gas, we support approximately 20% of all offshore operations globally, and that is then it's more about the helicopter traffic, the vessels moving to and from the platforms offshore, and also the operations at the platform, forecasting both the weather, but also the motion of the vessels and the motion of the platforms, motion of the helidecks. And based on that, the operation is offshore decide whether to operate or not. Also, lately in the last few years, we have had a quite rapid growth in the offshore wind industry. So today we have been involved in 30% of the offshore wind construction projects and the operation projects worldwide. And for the land-based industry, that is something we mainly do in the US, but also to a certain degree in Asia. And that is very much related to severe weather, like typhoons and hurricanes, tornadoes, hail, etc. And then it's typically a very large corporation like Facebook, Coca-Cola, Whataburger, etc. that are so large that they have weather as part of their business processes. And lastly, we have we actually own a large TV channel in Brazil, providing weather information in that region. So now Reza will talk a little bit about. We'll talk about two projects that we're working on, and Reza will start.
Sure, thank you, Torleif. So the first projects we have for today. Oh yeah, now I can start my video. Okay, thank you. The first project we have for today, it's the electric grid monitoring using satellite imagery. And the reason is the electric grid is in the front line of climate change and the impact of climate change on our infrastructure. By any storm, hurricane, earthquake, flooding, the first thing we lose is electricity, and electricity is a key for keeping our house safe, warm, and sound. So basically, we do need to keep lights on in any circumstance, but unfortunately, electric grid is the most vulnerable part of infrastructure we have. So next one, please, Torleif. So, and what we are seeing these days is a great revolution in terms of availability of satellite data. We see a high number of satellites are going to the orbit every day. The cost for launching satellites and putting them in the orbit is tremendously reduced, from hundreds of millions of dollars coming to maybe hundreds, thousands of dollars. And we see this huge potential to use such space-based data to see what's going on the Earth. So Torleif, do you want to add something here?
No, I think that is very good.
Very good. Next one, please. So when it comes to the electric grid, we see the vegetation, one of the major reasons for outage and basically faults or some kind of risk in electric grids. And the reason is that in a lot of places, the transmission and distribution line pass through cities, fields, farms, mountains, the nature, and they get exposed to the vegetation. And in a lot of cases, these locations are far or hard to reach, or maybe because of the network is so big, so vast, it's not easy just to check every point of the grid. And electric utilities around the world spend between $60, $50 to $1,000 per kilometer of line for inspection and cleaning the power lines right away. And the way they do that is basically by dividing the power line right away to different zones, like the awareness zone, notice zone, and alert zone, where the tree or the branch gets so close to the line, and they try to keep the line clean. Here, in the right-hand side, we have a picture of the western part of the Norway, near basically in Hordaland, and you can see with the proper satellite imagery with 50 centimeter resolution, we can see huge amounts of information regarding that area. Where are roads, where are fields, trees, farms, even the fence for the farm, and all those kind of specifications. So we are starting our team to think about how we can automatically extract all this information regarding the land aspects, the power lines, the vegetation, and provide a situational awareness for the operator. And that was the start of our project supported by the European Space Agency on using high resolution satellite imagery for grid monitoring. Next one, please. So we develop an artificial intelligence algorithm to automatically extract the vegetation location, where they are, how far they are from the line, and how much risk they provide for the electric lines in different environments, different type of vegetation coverage. And just to give you a sense how this algorithm works, in the left-hand side, we have this animation, and you can see a sliding window move on the line and look at the satellite imagery and basically measure, characterize, and calculate a risk function based on the threat we see from the vegetation around the power line, and then come up with this kind of color code which is something similar to what we have in a Google map or these navigation softwares to find our way and have information about traffic congestion. But in our case, we provide this vegetation-based risk, something similar, but for the power lines. And in that way, as you see on the right-hand side, we pick an area, again, for the western part of the Norway, because we are working with the electric company there. And we show that we provide this kind of risk-based map for the grid, electric grid operator, and they can see in some red zones, it's where they need to pay more attention to the vegetation and provide more insight. And you can see that 95% of the locations are clean, they are green. And it means that they don't need to send helicopter or a ground patrol or drone to do the inspection and spend a lot of money and time to get this image. With one satellite image, with a fraction of cost, we provide them this situational awareness, and in that way, they can optimize their costs and just pay their attention to where it's needed, and maybe just send a drone or helicopter to the red zones. Next one, please, Torleif. We also went beyond the vegetation management for the electric grid. We also look at the urban areas, and we test our satellite-based AI algorithms for estimating the impact of hurricanes and storm on cities. For example, for Hurricane Michael in Florida, we use these algorithms we developed to see what is the level of hurricane destruction on a city after the hurricane. And just to show you an example, if you look at the left top image is a part of a road, and the left bottom side is what a machine using our algorithm will see that area. And you can see the color code shows the light color shows the location of the trees and the roadway and the buildings. And after hurricane, we can clearly see a tree cut the line, cut the roads, and also consequently cut the power lines and makes a road closure and a power outage. And using this satellite imagery technique, we could estimate the destruction of the hurricane in the whole city in a very quick time. And the reason we are interested and we believe in using the high resolution, high quality satellite imagery rather than the drones or helicopter is that because simply after massive natural disaster, because of the weather condition, the drones are not maybe able to operate in that weather condition. Also, they are limited by battery range, the size, and a lot of other technical aspects. However, with satellites and technology like SAR, which can go through the clouds, even we don't have the cloud coverage obstacle, we can get a very clear and reliable image and from the situation on the ground, even after the disasters. I think that's it. Torleif, anything else you want to add?
No, so I think that was very good. So that is one of the areas that we work on, and then combining the weather data together with the information on where the vegetation is adding another dimension to get a good understanding of the risk. So another thing that we are working on is like I mentioned, the shipping industry and the problems that the shipping industry has with the weather. So to the right here, you see just a report from I think this year in September, and the problem is that during different weather conditions, you get congestions in the ports. And I would say that a thriving port, a functioning port, that is key to a smart city. And likewise is the data sharing and utilizing the data you have at hand to automate and make the city smarter. So I think the port is a very just like the water, together with the waterways as mentioned earlier today, and the ports and the shipping industry is a very important part of making a city smart. So to mention a little bit about what StormGeo do today. So you can say that for the shipping industry, you typically start with the planning of a trip or maybe multiple trips to the right, and then you have the possibility to optimize around the planning. Today, we do a little bit of work here, but the majority of the services that StormGeo provide today is in the ship operations part. So that is after you have left the port and when you're on your way to the next port. And typically we look at the fleet performance. We collect data from the ships. So that could either be noon reports or also directly from the engine, depending on the company. And then we create insights based on that, informing the owners or the charterers, the captains on the condition of the ship. We also do planning and navigation, so basically classical mapping, and then we have the route advisory, which is related to the weather. And lately, we looked at our data because we have collected a lot of data about the shipping industry over the last 30 years. So we know where there is congestions, we know where the problems are, and then we started to look at the CO2 calculations, the CO2 emissions from the ship operations. And we see that by having routing services alone, you can save approximately somewhere between 3 to maybe 10% in the best cases by optimizing for weather on the route from one port to the next port. But what we saw was that there is actually a lot of CO2 emitted during waiting to get into the ports. So we see that I think we calculated that just looking at our customers, the emissions because of the unnecessary waiting time outside ports is approximately 3 million tons of CO2 per year. And as a comparison, the city we live in, Bergen, where the Bjerken Center is also located, is emitting 800,000 tons of CO2 every year. So it's 3 times the emissions of a medium-sized city. So it's a quite major problem. So looking at the kind of services provided, if you look at the typical journey, you have many weather dependencies. From departure, when you are loading the cargo, there are many types of cargo that you can only load under certain weather conditions. Then, of course, you have the wave, the currents, the winds, and the severe weather on the route. Where you can actually optimize and save fuel during the voyage. And I think this is also for the autonomous ships. This is having the optimized routes. It's really an enabler to allow these longer distance autonomous journeys. And then you have the problems when you come to the port, like we saw the example with the typhoon. That weather conditions can cause congestions in the port, and we know when the ship is on the way, and we know when it's supposed to arrive. And we think that having a better data sharing and a better coordination between the different actors in the industry, that is what will allow the reduced emissions or reduced waiting times in the port, and by that reduced emissions. And once you crack that nut, there is also, of course, then you can start with the demand planning at gate, etc., and save additional fuels and making the cities even smarter. So to finish off with this slide here, so to repeat the message that the shipping industry in the ports is an essential part of the smart city, and so is the weather, and optimizing for the weather, optimizing the ports, optimizing the shipping industry is key. And we at StoneGeo, we see that to enable this these reduction in emission and the smart cities, there is a need to collaborate and share data, and we are definitely looking for partners and willing to do that. Yes, thank you.
Thank you very much, Tulus and Raza. After your presentation, I thought that maybe I have taken the weather information granted for such a long time, because all this small weather information can turn into a huge business potential, and that was really an eye opener. Thanks very much. Our next speaker is from Korea, and her name is Shiun Yang. Shiun Yang is the Director of International Cooperation in the Korea Methodological Institute. She's in charge of supporting methodological industry in Korea to go abroad, as well as the official development assistance projects. Shiun Yang, the floor is yours.
Okay. Hi, how are you? I'm Shin. Yeah, good to see you. Can you see this slide? Yeah.
No, not yet.
Yep. Hold on.
Take your time.
Okay.
I see something changing. Yes.
Okay, so okay, my name is Shin Yang. Yeah, I'm a director of International Cooperation Division at Korea Methodological Institute. We are the affiliate of a Korea Methodological Administration. And what we are basically doing is managing National Meteorological Observation Network. And we are also in charge of supporting private sector, in particular for the meteorological industry in Korea. And as a part of the job, we are supporting R&D project. And what I'm going to introduce today is about the smart city weather solution development in our as a part of our R&D project. So let me begin with a brief background about our R&D. As you guys well know, Korean government is pursuing smart city policies to solve urban problem, and we decided to develop a national pilot smart city in Sejong and Busan. And we also have an implementation plan for the National Pilot Smart City. And in that plan, we identify what kind of weather services and weather solutions are required for the smart city in the area of mobility, healthcare, energy, safety, and infrastructure. So KMA, Korea Meteorological Administration, also have our own implementation plan for development of the smart city weather solution. So we have a 5-year plan. So starting from this year, 2020, we began designing the prototype. And probably from next year, we are going to actually develop the technology and solutions. And from the year 2023, we are going to open the pilot operation services. And then we are aiming to open the real service in the year 2024. So currently we are in a designing prototype stage. So I'm going to introduce about that. So how we could do that by using our R&D. So currently we have a 4 R&D project. 2 are designated and the other 2 are item designated. And designated projects are much more stick to our policy and our implementation plan. So today I'm going to share these 2 designated projects. So the first project is, the title is Designing Smart City High Resolution Weather Observation System and Weather and Climate Platform. Actually, the title says all. So the first task is designing smart city high resolution weather observation system. As you can see in this picture, Korea have very well equipped meteorological observation network we have over 600 surface observation station. We have a 15 weather radar. We have a 25 upper air observation station and marine observation station as well. And recently, we even have a meteorological satellite. So, which means that we have a very dense meteorological observation network. It is much denser than the WM recommendation. And what we are going to do with this existing observation network, we are going to combine this together with the newly installed IoT weather sensor. So let's say this red dot is the existing observation station, and followed by the implementation plan of the Ministry of Land and Infrastructure and Transportation in Korea. They are going to build much more IoT weather sensor in National Pilot Smart City. By combining this observation network together, we could actually improve the resolution of the observation network, currently from 13 kilometer by 17 kilometer up to 175 meter, which is very dense and very high resolution. And what do we need to do next to build this high resolution observation network? We need to develop the technology to converge these two observation network together. Because the IoT sensor does not have a standard when they install, or when they don't have a methodology, a standard methodology when they observe the weather event. So we need some technology to connect this data together to make it as a same standard. And to secure the accuracy and the reliability of the data, what we need is a quality control. So our research project is also contain this quality control methodology development as well. And how we could do that? Uh, Firstly, we are going to do the comparative observation with the two IoT sensors together with the existing observation station, at least for 3 months. And by doing so, we will see the accuracy of the data from the IoT sensor, and we will also check the error range. And we are also going to develop the QC algorithm and the verification methodology. Actually, KMA already have our own QC methodology. So based on that, we are currently designing the prototype for this methodology and the algorithm as well. And the last thing would be the building metadata and the standardization methodology. I'm going to introduce later, but we also have to connect this massive observation data to other data platforms. So we need this job as well. And the next task for this project is designing smart city weather and climate platform. Ministry of Land, Infrastructure and Transportation, which are the major entity for developing National Pilot Smart City, they are going to build the AI big data platform. And this platform will integrate all the data which are needed for the smart city, such as transportation, education, environment, healthcare, something like that. And they are going to use some AI analysis, and then they will extract some meaningful information for the users in the smart city. And what we are going to do with this big data platform, by using our existing observation data and the newly collected observation data from the IoT weather sensor, we will also integrate it and then upload all this data into smart city weather and climate platform. And this platform also have a meteorological digital twin. I will go over this later. And we are going to connect this weather and climate platform with the AI big data platform, and also meteorological disaster prevention portal operated by the KMA, and also weather and climate big data center operated by my company KMI. And we will provide some meaningful information to the users. And next is our second project. The title is Prototype Design of Smart City High Resolution Weather Analysis and Forecast System and Weather and Climate Convergence Technology. So in the previous project, we design the prototype for the high resolution weather observation system. And what would be the next stage? Next stage would be the weather analysis by using those observation data and produce some forecast. So this project is about that part and how we could do that. We are going to use mainly three technology. The first one is numerical weather production model, which are very commonly used when we produce the forecast information. And we are going to use the newly collected urban weather information from the IoT weather sensors. And we are also going to apply cutting edge technology like the AI or deep learning. And by doing so, we are going to develop high resolution 3D weather analysis and forecasting system. And I'd like to show you a short video clip about this. I hope this will be look good for you. This is a 3D map, and then on this 3D map, we actually visualize the wind direction and wind speed, and by the color, we could show you the temperature. So by using this kind of 3D observation, forecast and analysis system, we could see the certain urban areas weather condition, and we could provide much customized weather services for the users in smart city. Okay, and the next task for our second project is prototype development and design demonstration of weather and climate convergence technologies. So what we need to do is to identify what kind of weather services are required and what kind of services are needed for the smart city. So in this R&D project, we are uh, uh, developing the prototype for the fog detection based on AI. As you can see, by using the CCTV image, we could detect the fog condition, and also one of our research, Worldtech, they are developing a world weather risk service by also using the CCTV image, something like that. We could extract by using some algorithm the weather conditions like this, and also giving some warning for those who are driving. And the last task is design digital twin for meteorological research. So I'm pretty much sure that everyone knows what digital twin is. And what we are going to do with this is use this as a test bed for our newly developed forecasting technologies. So by mapping some results from our simulation or a new technology, we could visualize and we could simulate the actual data from our newly developed technology. So this is what we are doing. So it is all my presentation. Thanks for listening.
Thanks for the wonderful presentation, and then it was quite amazing that Korea has the highest density of the detecting units. Just a short question to Sian. I was just wondering because I don't know much about Methodological Institute, but I know that you're supporting the ODA program and so on. Do you also have planned to do some international cooperations, like with maybe perhaps in Norway for the near future, or?
Yeah, I would love to. I would love to do so. Actually, for the ODA project, we are mainly cooperate with the developing country. However, we are widely open to cooperate with the developed country like Norway. Yeah, we are love to do so. Thank you.
Yes, and then when the time allows, COVID-19 ends, we will love to have you in Norway as well. Thank you very much.
Thank you.
Okay, let us start our last but not least topic of the day, which is the hydrogen mobility. We have Øystein Ullebøk from IFE in Norway. He's a principal scientist at the Institute for Energy Technology, associate professor at the University of Oslo, and the director for the Norwegian Research Center for Climate-Friendly Technology on Zero-Emission Energy and Transportation System for Road, Rail, and Sea. Øystein, can you hear me?
Yes, can you hear and see me?
Yes, perfectly. Thank you.
Let me try to share something with you here then. Can you see my screen now?
Yes, but it's not in the presentation mode. Do you think
Oh.
you can change that to the presentation mode?
Yes, I'm trying. There we go.
Wonderful.
Yeah, okay. So thanks a lot for the invitation and for the nice introduction. I was actually in Korea in 2014 and really enjoyed your country. I was traveling around. I was there at the World Hydrogen Energy Conference in 2014, and there was very interesting developments. And ever since, there's been a lot of interesting developments on hydrogen in Korea and in Norway. So I will speak about the Norwegian case now. I thought to organize my talk in two parts. I'll give you just a brief introduction from where I'm coming from, and to understand why and how we're doing things in Norway. I think we also need to put it a little bit into a European context. I would also like to speak about this research center that I'm heading. It's a research center on zero emission transport, where we focus on battery and hydrogen technology, and then give you some case studies on some recent developments. So that was the layout for today. IFE is a research institute, private research foundation, about 600 people. We were established as a nuclear research institute in 1948. There you see the founding father, Gunnar Anders, together with Albert Einstein. We are actually decommissioning now the nuclear reactors. We have a nuclear research reactor and also a test reactor. Both of those will be decommissioned, but the point of this slide is to show that we started very early with hydrogen. We had our first publication on hydrogen storage in metal hydrides in the 50s, early 50s. And then we moved, of course, into the other areas that are more known to society now. For instance, we were there in the offshore development, and the rest is history. Now there's a huge offshore industry in Norway. We also were instrumental in establishing energy efficiency in industry in Norway, and that's now taken care of, and to the point where industry is one of the best in class to save energy. Wind power in the late 80s, and subsea in the early 90s. Subsea, of course, is very much an enabling technology to the operations on the sea floor bed. And then in the later years, solar power with photovoltaics, and now last decade, lithium-ion batteries developments. So in many ways, as normal, for research institutes, we are 15, 20 years ahead of time, and it takes time to develop these new technologies, but at some point they become commercial, so it's very encouraging. So the latest one is on the Zero Emission Center that I'm heading. It's a national research center. To put it in context now, so we are able to reduce the global or the greenhouse gas emissions in Europe in total in the stationary sector, but we have challenges in transport. So the projections for Europe is actually a quite significant increase. They're planning for an increase in the total passenger traffic. So you see that to the left there, and also in the freight transport, significant increases are expected. And so obviously then some of the challenges will be when we want to go to zero emission. For instance, if you I did a back of the envelope calculations here last year just to see, what if we did a conversion of 250 million passenger vehicles in Europe and convert them to battery electric. That will be a tremendous challenge, because then we would have to have quite a lot of charging capacity, actually as much as we have installed in terms of power production in Europe today. So maybe not so realistic. The rest of the talk, I'll speak about hydrogen. We also did a calculation just to put it into context. If we did roll out a part of the fleet that is today 6-7 million trucks and about 1 million buses. If we said a fraction of those are operated on hydrogen, what would happen then? Well, we would have to put up quite a few hydrogen refueling stations. And we have started this, but it's a huge task. In Norway, the targets are to fast track this. So since we have a renewable energy base of close to 100% on a good year, we export hydroelectric power through sea cables down to Netherlands and to Denmark, and we're in the Nordic energy mix. So we are in a very good position because we have a lot of hydroelectric power and more wind power is being built. So for us, it's easier to go quite fast to this electric situation, also electric transport, either than battery electric or hydrogen electric. And so there's a national transport plan where we want to go to 100% zero emission light duty vehicles and trucks by 2025. And that's the new car sales. So we're in a very good shape on the light duty vehicles. I think there are about 300,000 passenger battery electric vehicles now in Norway. So that's about 15%. And then we are starting now with the buses and also trucks. So by 2030, we would like them to be zero emission on the medium heavy duty trucks, and 50% of the new heavy duty truck sales should be 50% should be zero emission. We also have goals, very specific goals on the operation of our ferries to go to low and zero emission. So this research center that I'm heading, we are a group of about 100 people. It's a researcher-driven center, 50% funding by the Norwegian Research Council, and then 25% by the research organizations, 7 performing research organizations, including universities. And then we have about 22 commercial partners and the 7 public partners, and they also contribute then with 25% of the funding. So we do research from materials up to component level to system level. We focus on both battery and hydrogen technology, and our focus is on the heavy duty applications. As we see, these are areas where we can play a difference, and particularly in the maritime sector, we've had a lot of work because there we have a nice value chain with many commercial and industrial actors in Norway. So we have a project going on now on the hydrogen trucks, but it's just a demonstration project. There is then Oslo, which is this food distributor, fresh food distributor in Norway. They have ambitions to go to zero emission on their distribution trucks, and they're testing out all the options, and they have one project also testing out hydrogen and fuel cells. We of course have suppliers in Norway and in our consortium in Moses. Nel, they provide hydrogen stations. I believe they also have bilateral collaborations now with Korea to roll out stations there. And then we have also quite famous company, Hexagon, providing composite cylinders. So these key technologies can, namely then the alkaline and the PEM electrolyzers and the storage tanks for hydrogen, can also be applied in the maritime sector. So we are looking now specifically into the high-speed passenger ferries. And it would be wonderful to see if we can have some of these exported to cities around the world and have them as alternative means for public transport. I know that this is a goal for Oslo, to have 1 or 2 of these operating in the Oslo fjord. I won't go too much in detail on this project, but I would like to bring to your attention that we started very early in Norway to make the system ready for hydrogen vehicles. Personally, I was involved in the light-duty vehicles. We had a development on a small battery electric vehicle that was rebuilt for hydrogen operations. So we have the HY registration signs, and that applies then for the small-scale vehicles. We only have about 160, 70 passenger vehicles on hydrogen. But now there seems to be a stronger interest for the trucks and the buses. So that's why I would like to take you into this, just to give you some examples of what we do in terms of maybe a little bit more high-level research for this audience, but we of course do detailed research all the way down to the component level and system development. So one study we did was to see if we, how would it look like if we designed a system with the water electrolysis along the route between, so have some stations built in Oslo and in Trondheim, and then also along the maybe like a midway point. So we designed, we looked into this in detail and to see what's possible with the fuel cell electric trucks. And we looked at the transport demand today and the projection for 2030. Today, of course, there are no zero emission trucks. And then we said, okay, what would happen? Is it feasible, techno-economically feasible to do this with 100 trucks in 2030? So then what you typically do is you look at the profile. So we have tools to sort of estimate the energy demand for these routes, and with more sophisticated technology, of course, it's very easy to do this these days. And then we can have some simple or more sophisticated models of the vehicles to estimate the energy demand. And we figure out that the fuel demand for hydrogen was about 40 kilograms for this route. So we are collaborating internationally with some partners on this vehicle modeling. I don't want you to pay too much attention. You can have it for future reference, but this lower left-hand figure shows when is it cost effective. So basically everything beside to the left of the black vertical line there, you see that it breaks the x-axis at about 70 Norwegian krones per kilogram of hydrogen. Everything to the left there is cost effective. This is the 2030 scenario. We weren't able to produce this plot for 2020 scenario or the 2025 scenario. But what's interesting about this is that with the learning curves we see on the hydrogen refueling stations and the trucks, which are quite realistic according to our research, then it is possible to design a system, a complete system, where you have the trucks and you only need 10 trucks per station. So a small station, relatively small station of half a ton of hydrogen per day would then suffice to get this cost effective. And this is very interesting. And this complies with our theory that we need to think holistically when we build up these fleets and build fleets first, because to make the production of hydrogen cost effective, you need to have a certain throughput. So we have previously shown that you need about a ton a day to make a cost-effective station, and that station needs to be quite frequently visited. So building up infrastructure for fleets is a good solution. We've also looked at this region, Oslo region. Oslo region, the capital region of Norway, including Viken, has a population of maybe 1.5 million, a little bit more. And there's a lot of traffic going through. So we wanted to look at, so we did a feasibility study earlier this year, and we're continuing this project now. And we had some data from about 1,000 trucks. It's only 5% of the fleet in Norway, but at least it's a quite significant statistical amount. And we interviewed operators and we looked at some scenarios. So we don't have to go into all the details here, but again, we had to look into an optimistic scenario called the sunny future to see what is possible with zero emission trucks. And what we see then is that we can actually, out of those 1,000 trucks, convert about 50-50 hydrogen and battery electric. And then you see a map here showing the feasibility then. So then we made assessment based on technology availability, both on the vehicles and the fueling stations and the charging, fast charging for the batteries, and driving range, weight. Some trucks carry more weight, some carry more volume. And we've looked into the details, and we are continuing these studies now for the capital region, because the city of Oslo is very interested in. They actually have a plan now to implement zero-emission trucks in the capital region. Since this is such a big effort, we have joined forces. So we've made a spin-out project out of Moses together with some key research partners listed there, with SINTEF and Transport Economic Institute and the university up in Trondheim. And we are now looking at the three major regions in Norway: Bergen, Trondheim, and Oslo, and all the corridors between, and we want to do an overall optimization then to look at both how we can solve the problem with battery electric and fuel cell electric. Last example is on zero emission buses. So very ambitious strategy. The city of Oslo just announced that they will go for this. It's been politically decided. So by 2028, there will only be zero emission battery electric and fuel cell electric buses. It's hard to say what the fraction will be. Right now, we are mainly looking on the battery electric buses because of technology availability, but we have looked at the whole fleet, and we see that there are quite a few routes that will have some challenges with just going battery electric. Plus, there's a heating demand in the winter. So, and also there's quite high infrastructure costs on not only on the hydrogen, but also on the battery electric for the fast charging. We also looked at an issue that is a little bit challenging, and that is queuing. So one example of that is that the study we did now with the city of Oslo and also the region around is to see if we could come up with a more cost-effective solution for slow charging. So the part of the fleet could be slowly charged with hydrogen. And so we made a study on that and have made a report that will be published very soon. And it shows that the total cost, the fueling cost of hydrogen really goes down if you can do this slow filling at the bus depot. Maybe this concept could also be applied to trucks. So you can do a combination of slow fueling and fast fueling then to cut the costs. So conclusions. Norway has clear ambitions on the rollout of zero emission mobility and transport over the next decade. And we are looking into the possibilities of hydrogen fuel cells, especially then for the heavy duty trucks and buses. And the main challenge we see now is really this optimization, and we're proposing different research projects on that. What you see in the slide there is one of the test facilities we've built. So we've operated a hydrogen station there in the early day, one of the first high pressure hydrogen stations in Europe, 700 bar, together with Nel. This is now being decommissioned, but it was useful, and I believe we've had Hyundai's refueling there. It's been very exciting to follow this development, and now we're going to the more large scale. IFE, we of course also do other work, so this is just to show that we don't only work in hydrogen, but we work in many other fields, and we have quite extensive set of laboratories where we do testing. Thank you so much for your attention.
Thank you very much, Øystein. That was very, very interesting. And then I have lots of things to ask you, but I will wait until Sehun Kim's presentation and then ask both of you questions, if that's okay. Okay, it is our last speaker of the day. It is Sehun Kim from Hyundai Motors Group in Korea. He is currently the head of Hyundai Motors Company's fuel cell division. As the director of the fuel cell development group, he led the successful launch of the Hyundai second generation fuel cell EV model, the Nexo SUV in 2018. Please welcome Sehun Kim.
Hello, everyone. It's my great pleasure to make a presentation in this meeting. I will introduce you the status of fuel cell technology and what is going on in the automotive industry also. So you will control my presentation file, yeah, Jason?
Yes.
Thank you.
It's up and running.
Okay, Thank you. Next page. Okay, so I use this starting page to, show people that what we dream really come true. So this cartoon is made in, drawn in 1965 by a famous Korean, comic artist whose name is Lee Jung-moon in 1965. So this was, I'm born in 1966, so it is even 1 year before I was born. It is about 55 years ago cartoon. So you can see here, going to the trip with the space shuttle, and you can see electric vehicles, moving roads, smart TV, smartphone, cleaning robots. Now, probably you all have at home. Autonomous vehicle and urban air mobility. It's a flying car actually, and you can see in the left bottom side, a bus is flying with tens of people. And you can have a telemedicine system and online learning. Well, in Korea, online, because of the Corona situation, online learning is, very popular, and, everyone uses it today. So it is a cartoon of 55 years ago, but as you see, everything is realized today. So what we dream, I think we can realize. But unfortunately, there is no hydrogen here. So I'll tell you a little bit more about hydrogen. Next page. Well, I'll skip this because everyone knows about the Paris Agreement, and we are just waiting US to come back. Yeah. Okay. Next page. Okay, this is the regulation, CO2 regulation in Europe. So in 2015, we had a regulation like 130 grams CO2 per kilometer, which means when we drive 1 kilometer, we were allowed, without penalty, we can emit 130 grams CO2. But from next year, it will be 95 gram. So this is NECD mode. So you can, and up to 95 grams, so up to 2020, most people, and this regulation goes to 2024, yeah? So most of the automotive country planned to meet this regulation of 95 grams CO2 by diesel and, hybrid vehicles. But now today, because of the Dieselgate, we cannot use diesel car anymore. So most of OEMs, stopped developing diesel engines already today. But the real problem will come at 2025 when it is 81 gram, because even only medium or small hybrid can meet this regulation. So if you are a company who is selling more bigger cars, you will exceed the regulation. And 59 gram regulation of 2030. This was made this year in the assumption that in the condition that the EU was planning to reduce 40% of CO2 by 2030. So in automotive area, it was 37.9% reduction compared to 2021 level. But now EU is saying that they will, intensify this regulation, not 40%, but reduce 55%. So many automotive companies are frightened about this result. Actually, I made this dotted line in 2012 because in that time, the target was to reduce 80% of CO2 compared to 1990 by 2050. So, but in the transportation sector, we should remove 95% of CO2 by 2050. So I made this kind of trajectory, but now it is exceeding. This is only one problem. And when we go to the second page, next page, please. Okay. So, maybe this could be presented afterwards, but I will just tell some, intuitive things for you. So actually, Jeremy Rifkin said, if there is a industry revolution, three things have to meet at the same time, which is communication network, power source, and transportation. Well, in the 19th century, we had printing, telegraph, and the fuel was coal, and we had, steam engines for railroads. And 20th century, we know that phone, radio, TV in the communication network, petroleum is used, and ICE vehicles. In 21st century, now we are ready because our communication is already, changed to internet, and IoT, 5G. And from 2015, between 2015 to 2017, I already know that in some places in the world, solar and wind is more cheaper, and hydrogen is beginning to be, thought in the government as the, energy medium for the future. And especially in 2020, this year, I think it is the starting year of hydrogen because all the countries have announced their hydrogen roadmaps, and all industry knows that we are going that way already. And we have battery electric vehicles and fuel cell, autonomous, and purpose, PAV and UAM. You're talking about new technology using hydrogen and renewable energy in the transportation sector, and I think we are in the starting point. So let's go to the next page. Well, because of these, many countries are already preparing hydrogen society. You can see in the right-hand side picture that Japan already announced in 2017 the hydrogen strategy or roadmap. Korea in 2019, and I know that Norway also announced in 2020 May. And Russia are also already made a hydrogen roadmap in this October already, and China also, I think, it's just a subsidy program, but at least they showed their roadmap, and also Morocco and Chile will come. So many countries announced it, but the biggest impact was, I think, Germany and EU. Announcement. After these announcements in June and July, energy companies started to move and investor companies start to move toward hydrogen society, and they are ready to invest. Next page, please. Well, now many countries is announcing carbon neutral by 2050, and also Korean government is planning to announce it soon. So in that case, now NGOs says, okay, if you guys really want to be carbon neutral also in the transportation sector by 2050, you have to ban the internal combustion engine cars at least by 2035. Yeah, because if you build one car, it will last for 15 years. So you have to stop selling it by 2035. This is a stronger threat to vehicle OEMs. Well, anyway, in the future, there will be only fuel cell vehicle and battery electric vehicle because that is the only truly zero emission vehicle technology we have at the moment. Hybrid and plug-in hybrid still uses engine. So I think these two technologies will survive for the future. Many people ask us what will dominate, but I think both will dominate. It only, the market share will be different from two reasons. I think the first one is which application do you use? So which mobility device do you use? Is it a small car or big car? Is it truck, bus, airplane, or ship? Yeah. So, you can use some certain portion, but majority, for example, like heavy duty trucks, you cannot use battery, technology alone. And I think most of the trucks will be adopting fuel cell technology. So the application area is one option, and the second is the situation of renewable energy of your own country. For example, countries like Japan and Korea, we cannot produce the renewable sufficient enough for our use because we are heavily industrialized. We, produce steel, cement, and ships and cars. So, and we are 70% mountain. So if we want to make renewable, we have to destroy our nature. So we have to import. And in this case, hydrogen, if we want to charge a battery electric car, we have to import hydrogen and produce electricity with fuel cell and then put it into the battery car. So which means hydrogen will be cheaper than electricity in Korea. Not today, but in near future when we have to use only renewables. Actually today, many people think that people who are driving electric cars, they think they are eco-friendly, but actually it is not. Korea produces almost 70% of its electricity from coal and other, natural gas and so on. 30% is nuclear. So in the future, we have to think about this all together and see what is the best economy in its own country. Next page, please. Now I want to explain you what is the fuel cell technology, state of art of fuel cell technology. Hyundai has developed fuel cell technology since 1998. And in 2013, we made the world's first mass production fuel cell vehicle, which is called Tucson. This car has only 5 years of durability, but performance was okay, but durability was very poor. So we could not produce a lot. We produced about 1,000 units in 5 years. But the vehicle in 2018, we guaranteed 10 years of durability and driving distance of 160,000 kilometers. And the driving ranges per charge about more than 600 kilometers. So this car has almost equivalent performance and durability as internal combustion engine vehicles. Only we have to reduce the cost by mass production and more better process technology. So when I tell you for the passenger car, I think only thing left is the reduction of cost. That's what is left. Can we go to the next page? Many people are fascinated about the commercial vehicle side, like buses and heavyweight trucks. We also mass produce fuel cell truck, and you can see this picture is an Action fuel cell vehicle, which is mass produced in July this year. And I think this year we shipped 50 trucks to Switzerland, and we'll ship in total 1,600 trucks to Switzerland. This makes business because in Switzerland, if you drive 1 kilometer, the tax is about $1. So if you drive 1 million kilometer, the road tax is $1 million. So that is more than the truck cost. So that is the reason why it makes business. And the driving range is 400 kilometer per charge and with 32 kilogram. But this is because we are using 350 bar tank, which and if we go to 700 bar tank, we can go to about 700 to 800 kilometer driving range per charge. So the customer can choose their storage system as they want. And buses, I think we are already there because road profile is not so severe than the trucks. Bus is only 15, 16 ton, truck is 36 tons, so it is more severe. At the moment, we do not have, put two Nexo passenger car system to the truck, but the power is not enough. If we want to put enough power, just the same power as today's diesel truck, we ought to put 4 systems, but we do not have the package volume. So now what we are doing is we are developing one 200 kilowatts system dedicated for truck and put 2 of them. Yeah. So in total about 400 kilowatts. So if from the fuel cell stack, so it can perform same as diesel trucks. Even today, people really like this truck. We let Swiss drivers, truck drivers drive this, and they were very satisfied with the performance. But what we lack is the durability. In the truck area, the commercial vehicle area, and the ship area, we need to develop more durability. And I think we could reach the required durability within 2-3 years. So not long time. It only we need some verification time for that. Next page, please. Oh, and one thing we do not have, we should not forget is we have to go together, passenger and commercial vehicle all together, because the mass production amount, the volume of the production is passenger car much more than the trucks and buses. So if we only go for truck and buses, it will be very difficult to have the mass production effect. Today, our truck has Nexus system, and it uses all the benefit, the cost reduction benefit of the passenger car. That's why it is, makes the business model. If we only developed for trucks a fuel cell system, it will cost $500,000 even today. So I think we should, use also passenger vehicles, fuel cell, and also fuel cell trucks at the same time. Next page. So what we are targeting is now we are looking, we are asking the train people and maritime people, asking for the requirements. What should be the durability of these ships, and what should be the power of each ships, so we can have the guideline to develop. So in Korea, we are trying to put our fuel cell system to ships and trains. And our final target is UAM, so urban air mobility, which is a flying car. The requirement is quite severe. So they require about 3 times more power density than today's fuel cell system. So we are trying to make it lighter and more power. But I think that should be, someday also realizable. Because, when we started our fuel cell development, I never dreamed of mass producing a fuel cell car at that time in 2003. But now we are doing it. And I think the fuel cell system UAM will come soon. And we are looking also for the market for emergency power generation, backup powers, because the backup powers do not operate for so long time, and it needs a fast startup. So I think our fuel cell system for the mobility side can fit very good with the emergency backup powers. So we are looking at application area also. Next page. This is my final page. So Hyundai Motor Company is aiming to produce about 500,000 units of vehicles by 2030. And we will produce about 200,000 systems more for other applications like backup power. And maybe by 2030, we could also use, when we reach the enough durability, we can also use it for the stationary power plants for steady power generation. We'll invest also, and we are increasing our production capacity almost double every year. I hope we can meet this target. And in order to meet this target, we need a clear government direction and investments from the energy companies for the hydrogen station. Without hydrogen station, it will not be realized. Okay, thank you very much. This is my end of my presentation. Thank you.
Thank you very much, Sehun Kim. Thanks for the wonderful presentation and all the overview of what Hyundai's been doing. Let me ask you one question each for Dr. Kim and then Dr. Ulebek. Dr. Kim, I know that you're quite heavily involved in fuel cell stacks, and then I'm sure you have heard what Oystein just mentioned about where Norway is going for their hydrogen trucks and buses. Just out of the curiosity, what kind of business opportunity can a Norwegian company have with Hyundai Motors?
Well, we are also very interested in ships and trucks. Every mobility devices we are interested. And actually, Norway is a big capacity and potential to produce hydrogen. So it is a perfect match. We will have to probably in the future, import hydrogen from Norway also. And we want to build also ship for hydrogen import and export. So I think we have a many application area where we can do together. Actually, not many people know, but before we mass produce our Tucson fuel cell vehicle, we had a long, about 3-year demonstration in Norway and Denmark, because at that time, Norway and Denmark had the hydrogen stations. But it didn't expand a lot since then, since 2010. So that is a really pity for me. But I hope Norway prepares hydrogen infrastructure, and we would really try to work together, putting our fuel cell systems to ships and trucks and buses and also passenger cars. So I think we can benefit from our technologies together. Yeah, thank you.
Thank you very much. Thanks for commenting Norway. And then Norway, we also have strong maritime nation as well as the fuel cell developers there. So we will definitely be able to introduce some of you. And then I am looking very much forward to travel to Norway with you sometime.
Mm-hmm.
And back to Øystein. You mentioned a lot of things about tanks, and then you mentioned hydrogen and Nel. Is there any plan for you to have? Do you think you can share maybe some of the companies that you can think of for the maybe liquid hydrogen storage tank companies in Norway?
Well, in the research center I spoke about in this Moses, we are not researching liquid hydrogen. Actually, that is a niche expertise that we have to build a new competence on. We are starting on the research level there, so there are no commercial companies in Norway, to my knowledge, that is developing the key technologies for liquid hydrogen. But there are companies like Moss Maritime that have experience on designing the bunkering system. So if you want to do in the future the long distance transport, like we do with LNG, there is know-how and technology companies in Norway that can go into the design of the larger vessels, typically those that would assist Equinor and the large energy companies in Norway in transporting larger quantities of liquid hydrogen. So we have that capacity on the large scale industry. In this first phase, when we want to roll out the smaller scale solutions, for instance, there's projects now with Wilhelmsen trying to develop a fuel cell driven ship that will be operated on fuel cells and will be using liquid hydrogen as the carrier and also as the capsule that you basically transport between our bases on the western part of Norway. That would require some new technology development that we are getting involved in with smaller companies in Norway, because then it will be storing smaller amounts of liquid hydrogen. So we are doing some research on these things in Norway now. So you have to have the long-term, large-scale perspective and the short-term. Right now, of course, we're building the economy also with the big players like Statkraft. The energy company Statkraft, very large on hydroelectric, with Equinor, of course, they're thinking about converting the natural gas to hydrogen, and the likes, So I think there are lots of opportunities here, and especially in the hydrogen in the maritime, I think there are some huge opportunities for collaboration.
Right, and you mentioning the hydrogen trucks and buses, maybe there could be some sort of linkage between Norway and Korea, also with your institute and then maybe Hyundai Motors in the near future. We also have one question from the audience to Sehun Kim. What's your vision for hydrogen station needed for fuel cells in distributed generation? For example, emergency power supply applications.
Well, hydrogen stations, backup power, emergency backup power systems has to have some hydrogen storage. So, for example, Microsoft is thinking of, storing their hydrogen because they need a lot of amount. Yeah, it depends on the size of the backup power. So what Microsoft is trying to do is a really big one, tens of megawatts. So for 24 hours operation, 48 hours operation. So what their idea is trying to store the hydrogen in the liquid form, and you will have the evaporating hydrogen. So they want to operate the hydrogen station at the same time to refuel their trucks and buses and passenger cars. That is one idea. But one thing interesting for power generation and hydrogen station is there were a long history idea that we will not use in the hydrogen station only for station, but it can be distributed power generators. Yeah. So you put fuel cell system in the hydrogen station and provide the electricity if the car you have sufficient hydrogen. So in Korea, many people refuse to have a hydrogen station near their home, NIMBY, but in one city we put a fuel cell, and we told the people in the neighbor that we will provide you electricity for the peak cuts. Yeah. Not normal time, but if there's a peak where the electricity is very expensive, we'll supply that electricity through our fuel cells in the hydrogen station. And the apartment cost goes up. Yeah. So the neighboring apartment also ask for that. Yeah. So they're liking it. So I think, in the future, many people, energy guys said we should go for distributed power generation and so on. I think in the future, fuel cells, hydrogen station can be at the same time, distributed power generations, generating, facility at the same time. Yeah, I think it can make a good combination together.
Yes.
We called it energy station actually. Yeah, in the
Energy
past.
station.
Yeah.
Wonderful, wonderful. Thank you very much for the vision, both for Se-Hoon Kim and Oysten. Thank you very much for your time and then wonderful presentation. Thank you. I would like to introduce our next speaker. By now, it is Sven Grandum for the closing remarks. Sven is the current director of the Innovation Norway Seoul office, and he has extensive experience as a science attaché in Norway in Japan. Sven?
Thank you very much, Jason, for that kind introduction and for taking us through these 2 hours. Very exciting. This is a time sort of overlap between Korea and Norway. That's the time zone that we can collaborate the most intensive. So thank you so much for that. Ladies and gentlemen, we have been through an exciting webinar program, I think. We have been touching upon the 3 smart city dimensions: smart ships, smart weather, and finally the hydrogen mobility. I think looking at and listening to the presentation, it's obvious that both Korea and Norway are heavily involved in smart ships and autonomous ships. We have learned during this webinar that actually smart and autonomous ships enables smaller and more flexible and cost-efficient operations. Combined with sort of an improved port logistics, this is for sure a very important and interesting development. I think the dimension of international standards, collaboration on that is really an important takeaway from this webinar. We can compete on technology, but collaborate on standards, I think was one of the comments that one of our 2 or maybe both speakers made. Smart weather, I think we all have a very important relation to the weather. In Norway, we usually say there is nothing like bad weather, only bad clothing. And perhaps in a smart city context, it has a little bit different meaning. But I think being prepared for what weather conditions will come is increasingly important in a smart, efficient, and safe society. And finally, the hydrogen mobility. I think the cartoon that Dr. Kim showed us, the forecast from 1965 is not very bad when it comes, or wrong when it comes to today's situation. I'm also born in 1966, like Dr. Kim, and I think the life was slightly different at that time. If it was better or not, I don't know, but it was different. I think he also mentioned the importance of the paradigm shift in the Green New Deal, combining network, power source, and transportation. I think these three elements are really important when seeing how we can implement smart and environmentally sustainable solutions. Bringing us to the final words, I think we have seen that Korea and Norway are working on similar issues. We seem to share some common goals, or many common goals. We are sometimes competing, but even more often we are complementary, and I think cooperation opportunities are many, interesting, and I think will create a lot of new solutions, also for a global market. So we, from our side, together with our good friends and partners, both in Norway and Korea, the Embassy and Innovation Norway, we would like to support you in developing this type of partnership, both on R&D, but also on the business dialogue. So we encourage you to stay in touch with us. Jason is well introduced through his excellent moderation role, but let us know what you would like to do more of in Korean-Norwegian context. So with that, I would like to thank the eminent speakers and both patient and important participants, for the co-organizers, the Norwegian Embassy here in South Korea and the Embassy of the Republic of Korea and Norway, the excellent technicians, interpreters sitting beside us here, and last but not least, Jason Park, our eminent moderator, putting this webinar together and taking us through this webinar during these 2 hours. So thank you so much for that, and I hope to see you all very soon again. Thank you.